Have you ever felt bored or sleepy in class and end up losing the whole lesson of the day? Don't worry, Mind Builders will help you to catch up with short interesting videos. Stay with us, you will make it through that exam or test you are worried about. In this video I'm going to show you how to resolve vectors into X and Y components. Assume that the car broke down and is being towed. The tow truck exerts a force that is not parallel to the surface but a force that is at an angle from the surface. If we can look at all forces acting on the car, we have a frictional force since the car is in motion. We also have an applied force exerted by the tow truck on the car at a particular angle. Lastly, we have a normal force and the gravitational force. Before you even begin any calculation about the car, it is important to resolve the applied force into its X and Y components so that you can deal with forces that act horizontal and vertical only. If we resolve the force applied, we will get two components X and Y. For X component we will use the formula Fx equals F cos theta. For theta we will use X. X is our angle between X-axis and the applied force. For Y component we will use the formula phi equals F sin theta. Remember that in both formula F stands for applied force. So Fx will act horizontally to the right while phi will act upwards. A car with a mass of 300 kg is being towed. The tow truck exerts a force of 90 N on the car with the angle of 30 degrees. The car is moving at constant velocity. 1. Resolve the applied force into X and Y components. 2. Calculate the frictional force. For Fx write Fx equals F cos X, then substitute from the formulae. It becomes 90 cos 30, punch your calculator, you'll get 77.9422864. Round off the 2 decimal, it becomes 77.94 newtons to the right. Don't forget the direction, it carries a mark. For phi write phi equals F sin X, then substitute. It becomes 90 sin 30. Punch your calculator again, you will get 45 newtons upward. For number 2 write the formula F net equals ma, where F net is the sum of all forces acting on the car. Then substitute the sum of force into Fx minus frictional force, equals ma. Since the car is moving at constant velocity there's zero acceleration. Substitute Fx and it becomes 77.94. Then it's 77.94 minus frictional force equals 300 kg, which is the mass of the car multiplied by 0. Transpose 77.94 to the other side. Then its negative frictional force equals negative 77.94. Multiply both sides by negative, you'll get frictional force equals 77.94 newtons to the left. Since Fx equals frictional force, it shows that the car is moving at constant velocity. Thank you for watching. If this video helped you, give it a thumbs up. Don't forget to subscribe and hit that notification bell.